All right. Hey, everybody. Good morning, good afternoon, good evening, wherever you are. We'll get started here shortly. I'd love to hear where you're calling in from. I myself am from Minnesota, central US, Canada, basically. So if you want to pop in where you're from, love to hear where you are and have a conversation. Before we get started, too, I have a few polls that I will pop up throughout the presentation. And in fact, I'm just going to open up one now, just while we get started, while people log in and get started. Um, yeah, excited to be here today. Really looking forward to talking about this topic called AI, chaos engineering, smarter strategies for resilient DevOps. Thanks to our hosts for having us on this webinar as well. And one other exciting thing personally is I'm going to the Killers concert tonight in Minneapolis. I have a poster behind my head that represents the last time they were in Minneapolis. So if you have any Killer fans out there for the band, mention that in chat too. Love to engage with you as well. All right. So again, my name is Matt Schillerstrom or Matthew. If my mom is watching this, sometimes she pops onto the webinars, but I'm a director of product management at Harness. I have been here approximately 3 years and a couple months. I've been working on our chaos engineering module, our feature flag module, as well as our service level objective module, database DevOps, and incident response. So I have a breadth in DevOps tooling. And I also help out as a community builder for our Litmus Chaos open source project, which we donated to the Cloud Native Compute Foundation a few years ago. So I have some companies listed here where I previously worked at before, and I'm just mentioning it because I've learned so much from my coworkers here at Harness, at Target, Excel Energy, and Gremlin. So everything I've learned and built up to my career is, on top of the shoulders of everybody else here. And at Target, I was a product manager for building out their chaos engineering program with an amazing team back in like 2016 to 2020. When I worked at Excel Energy out of college for 13 years, I was at a nuclear power plant, which was pretty interesting. That's kind of where I got my like reliability hat for software from that perspective. And then I was a product manager at Gremlin before this too, before I moved to Harness to build our platform as well. All right, so I know we're all here for the topic of AI, and I wasn't sure if AI was going to make my abstract for this presentation obsolete in a month because things are changing so much, but it hasn't. And in fact, I threw in this little prompt if you want to use this to build like a little cyberpunk chaos monkey, because today, when I talk about chaos engineering, it's not just about like the Netflix chaos monkey journey from what was like 15 years ago now. It's actually just really supercharged for doing even more than just like killing hosts or pods today. And kidding aside, I have a great agenda planned, and it even includes MCP. So here's a meme from Postman, one of my other favorite companies that tools I like using for DevOps. But I'll talk a little bit about model context protocol and like the open standard that's being built for AI agents and how to interact with those tools and services as well. So if you have any questions as I go through this presentation, feel free to pop that into the Q&A. And again, interact in the chat. Would love to see where everybody is. Like seeing, Washington State, great place to live. One of my coworkers is there. And he built our database DevOps module, which is really cool. But back to reality here. The agenda today. So I always like talking about like the challenges and developer toil that exists, because that's honestly like why we're doing chaos engineering, to improve our customer experience, but as well as our developer experience. Have a quick recap of chaos engineering, because I always recognize not many people are actually practicing it, or maybe they've heard a little bit, but I always like to level set everybody in that. Talk through like breaking through that chaos stall, why most teams hit that wall, and like how to design outcome driven chaos tests that reflect like the real world impact that we see today. And then I have some real world cases of AI improving fault analysis and system understanding. where I'll kind of go through like how you can actually run some tests on like AI agents or MCP servers as well if you're doing that today. I also will end with a demo before we get into Q&A. But yeah, please populate those questions in Q&A and I can get those around. And I just back on the agenda screen, if anybody wants to connect with me on LinkedIn, I have a QR code up there. I won't rickroll you with anything that I've done before to prior coworkers, but if you want to connect, love to talk later on or answer questions privately one-on-one. So let's talk about developer toil and what we face today. These are some news articles that have come up in the past few months, that kind of span all sorts of the software delivery lifecycle, whether it's burnout, because that's real, not just like problems with writing code, but problems with time management, workload, bad leadership, or just life, right? Like that's real and impacts us today. Or security, vulnerabilities that impact a company, um, or like AI adoption driving unmanageable spike in cloud costs. I know when I worked at Target back in the day when Kubernetes came out, we were playing around with Kubernetes and just building huge cloud environments, and we didn't really have to care about cloud costs as an engineer. Other people did, but even with the spike of AI, there's cloud cost implications, right? Um, there's outages left and right. We see that in the banking industry. We see that in retail and e-commerce. Um, but there's tons of impact that challenges organizations today, as well as developers, right? And that's really why I'm here today, right, talking about that developer experience and the toil. And this is a little chart we talked to our customers about and everything too. When we look at the developer's time, we're seeing 10% planning and collaboration, right? Maybe more. I always, when I was, well, I'm still a product manager, but back in my other companies that I worked at, we'd spend about that much time or more, because if we built the wrong thing, then we wasted all that time coding, right? So but what we see where developers spend time, planning collaboration with their team, interviewing customers, etc. Coding, which is like 30% of their time today, perhaps. And then software delivery, about spending 50% of their time building it, testing it, securing it, deploying, optimizing it. And then observability, about 10%. So like post-production deployments, seeing how it's rolling out and impacting customers. And what we're seeing is that, it's still like a broken software delivery tooling chain, right? Where we're seeing developers have like 60% of organizations are still releasing code on a monthly or quarterly basis. Where I work at Harness, most of our customers, go from, quarterly or monthly down to weekly or daily, right? Being able to give a developer and empower them with the ability to, you know, deploy code to production and then flip a feature flag and turn it on in an isolated way. Like that's the real power behind things. But we're still seeing as an industry, not that many people doing it. We're always seeing constant resiliency issues. 42% of developers say they cannot release code to production without risking failures. And this was based on a survey we did last year with hundreds of developers across numerous industries. We're also seeing uncapped security exposure as well, with 41% of developers don't have automated security and governance policies. Back when I worked at Target, like this was, Target got famous for their security breach, but they got even more famous for building like the best security program out there. And many of my security coworkers left to work at other companies, but what they built was, automated security practices and policies, right? So developers didn't have to like do that manually, right? And at Harness, where I work, we always pride ourselves in enabling this for developers too. We make it really easy for developers to do the right thing, and we make it really hard for them to do the wrong thing, right? And that just helps with the security posture in general. And then, like I had mentioned before, with cloud costs and efficiencies, 21% year over year increase in cloud spend, right? And that's not improving with AI, right? And I always like to put like a recent, news article or something, but McKinsey, a source is below on the page. They just published this yesterday, and this is relevant to site reliability engineers. And I know some of those people might be on the webinar today as well. Um, but what we're seeing, like with site reliability engineers, people who care about reliability and resiliency, the topic that we're here for today, like they can astronomically help financial benefits and non-financial benefits, as you see by these stats. And what's even more cool, right, is with the AI agents, the agentic workflows that are happening today, these stats are going to be built into agents, right? Agents helping with reliability and financial benefits. Now, again, not replacing humans, but just improving and making that better. In fact, the whole site reliability engineer, like it was like created to help out, like, to automate a lot of these manual tasks. Like back when I worked at Target.com and we were building out our S3 program, that's exactly what we did. We worked with the network operations center, the technical operations center, to see what manual things they were doing. And then we automated it with scripting tools and other DevOps S3 tools. But then agents are the new way that site reliability engineers are going to get more popular in writing, these agents to programmatically do these workflows, right? Because before, again, in my prior experience, we automated a lot of things for critical apps, a handful, and we didn't have time to do all of our apps. But now we're going to be able to enable all of our applications with these agents, right? So that we can scale it out quicker. And then another interesting stat to just from Google's DORA research from 2025 this year, right, is that we see 25% increase in AI adoption for coding, which is great. Like with tools like Windsurf or Cursor or whatever your favorite is, like you'll see definitely an increase in code production. But we're seeing negative trends with, that deployment cycle, like I saw with build, task, secure, deploy, and optimize. I'm going to pause real quick while I look at the polls here too. And the question I'd ask in the poll is, how familiar with AI-powered tools in DevOps? Some people say they heard of them, but not using them, not familiar at all, and just exploring options. And I would agree. Like most people are just exploring options today and seeing and testing, right? And that's what I'm doing too, like testing a ton of different tools to see how they can improve and fix things and learning and working with security to make sure I can, log in safely with, Google single sign-on, and that I'm protecting my data too, because there's a lot of fake AI tools out there too. So that's great. Thanks for answering that poll. I'll close that poll for now, and then I'll open one more poll as I start talking about the chaos engineering recap. So, what is your primary goal for exploring chaos engineering? So feel free to answer that as well. Great. And I see a couple of questions in here, so thanks for that. And I'll, talk through that at the end in the Q&A. All right, so a quick recap of chaos engineering. I always like to start with this kind of quote here. I've always found it useful for like why I started my chaos engineering journey too. But like if you don't know why it's working when it's working, you won't know how to fix it when it breaks. So as a former, engineer at various companies, I would always build stuff and maybe almost YOLO it to production, right? I would kind of know how it worked, but like I would wait for that incident to really reveal the truth, right? Whether I had it documented, whether I had run books, or even if I knew how it worked, right? But this quote really is kind of like my journey with chaos engineering, because I want to understand how something is working when it's working, right? When it's happy, when it's fun, when people are using it, when I have time, just so that when it breaks, if it's at an inconvenient time, like on somebody's birthday or at 2 o'clock in the morning when I'm sleeping, I know what to do, right? And that's the whole purpose of chaos engineering, is that proactive testing. Again, you're not, breaking things with a hammer on purpose. You're actually just proactively measuring the resilience, measuring that failure that can happen so that you know how to respond, right? And most of the time, when you proactively inject failure into your system, right, then you can fix it ahead of time or create a run book or document, or at least just know that that issue exists in your environment, so that if you do get a call at 2 a.m., you can at least be like, oh, I know how to fix this. And we purposely chose not to like fix it 100% because like it costs too much or something. And I'm okay with like responding and fixing it. Um, all right, another like meme type slide here with chaos engineering is a lot of people, chaos engineering has been around for a long time. The concept of resilience engineering has been around for even longer, which is broader than chaos engineering. But chaos engineering is important today because like technology and standards change, right? And this is a joke. I'm when I was so I'm in my 40s now, right? And my car seat growing up was like this bathtub seat in the back of my mom and dad's like station wagon car, right? So not very safe. But even further back, this is what child seats look like. And in fact, child seats were often just created to elevate the child up so they could see out the window in the vehicle, right? And this, like, looking at this is kind of humorous, but child car seats have evolved. My friends with kids, they're in this like space contraption in their car with some that kind of rotate if you get in an accident and stuff too, which is incredible. But testing technology has changed, right? So you need to do something new, and that's where like chaos engineering comes into play, right? Because technologies have shifted and changed, and you need to do new ways to do testing. And at the end of the day, like chaos engineering is really about that scientific method that you learned in grade school, right? Where you're selecting a system, running an experiment and hypothesizing like what's going to happen, right? Like what's going to happen if I turn the server off or if I add 1 second of latency in between my application talking to my database, right? But you run the test, you think through it, you observe the results, and then you make improvements on it, right? Or you get a badge that says you're successful and you're resilient to this issue that's happening. But it's really simple like that. And like what that can look like in the real world, got a couple of examples right here. Um, so Global Payments talked at KubeCon North America this past November about this brand new distributed database that they're putting out globally, right? And it was a huge investment, but they wanted to make sure that they could validate the resilience that when they turn this on, that it would support their high transaction volume of everything, right? So the way that they protected this investment was by using chaos engineering. So they put their system through a gauntlet of tests to make sure that, again, when they turn this on, that it would work, right? So again, they wanted to understand how it was working and what their failure modes were. But it was a great way to protect that investment. It's kind of how I talk about it. Another one too. So like this is, I know there's a lot of technical scripts on this screen too, but another great use case with chaos engineering too, especially if you're on Kubernetes, right, is validating that the apps can stay resilient through startup conditions or pod restarting, because that's a normal behavior of Kubernetes with pods restarting. So we can actually take like a script like this that measures the startup time of a pod against your application, and then run a test to purposely restart that, measure the time, the boot up time basically of your server, and then make sure it's resilient, right? So it's not just about injecting faults into your system, but it's about measuring the resilience of your whole system from start to finish. And then one more too, which isn't really interesting. So everybody seems to be using service meshes today, and Istio has some built-in chaos faults that you can run. But another customer, like we help them leverage those built-in tests that Istio provides, and we wrapped it with our harness chaos engineering product to provide like a really resilience score. So again, we were able to inject the fault through Istio, but then we were able to measure the resilience with our product too, just so they could have a repeatable test cycle and give it to more teams. So again, with chaos engineering, it's injecting the controlled fault, observing the expectation, but then realistically measuring the score from start to finish. And then just where we see that automation happen, we see a lot of people in pre-prod, performance test beds, in QA, in dev, and then eventually production. What I like to say is once you've stopped learning in the lower environments for these proactive tests, then you can graduate into production to run it, right? And similar to how we promote code through the software delivery lifecycle, you can promote these chaos tests from lower environments all the way to production. But again, from an industry perspective, for the past 10 years that I've been doing this, with people doing it longer than me, lower environments, are for the win. Definitely just start with everything. And where we see chaos engineering theming into for major use cases in the industries, obviously like financial services and their highly regulated environments, IT disaster recovery scenarios, proving out that the DR testing can audit and serve those regulatory requirements. And from my experience, DR testing was my main use case when I worked at Excel Energy and transitioned to working at Target. We were building, once a year DR tests. So we're taking that like once a year snapshot of reliability to prove that we could do it. But then we shifted into that proactive chaos engineering mindset where we could enable developers to do DR testing on their own microservice more frequently, because changes, as you know, like people are doing new deployments and releases daily, weekly, and that once a year DR test soon becomes out of date with everything. We're also seeing like the highly scaled environments, like I mentioned before, too, with like globally distributed databases need to be validated, and then Kubernetes environments, just in general, right? Kubernetes has self-healing capabilities, is really great, but the applications that we write, that we put on Kubernetes, might not be resilient. So we have to know how to handle those failure modes and everything. I'm just going to check the poll real quick as well. So let's see. What's your primary goal for exploring chaos engineering? So improving reliability, preventing outages, and not sure yet. Great. So the people that answered, not sure yet, hopefully some of these past slides gave you some like evidence for why you should, whatever you want to call it, whether it's chaos engineering or reliability engineering, like hopefully you now know some like outcomes that you can achieve with it. And for the people, on the webinar, like whether you're SREs, QA, or developers, or DevOps, we are seeing a lot of QA and performance engineers lean into this practice. That's honestly where we got the most bang for our buck at Target. I partnered with our performance engineers and QA testers to stack the habit of chaos engineering with what they're already doing. So just as an example, like simulating load testing for Target.com, 100,000 orders per hour, and then coupling it with injecting like a network turbulence or failure test to see how Target.com would handle the load of people buying like Funko Pops when they get released, but then coupled with that other habit of like the network outage, right? Can my system still serve my customers through all these disruptions and everything? But yeah, also SREs, they're protecting production, kind of the gatekeeper to making sure production stays up. And then developers are not in third place, right? Save the best for last year. But developers are now, we're giving them tools to do testing on their own, similar to unit testing and functional testing, which I'll talk about a little bit later as well. All right. I'm going to close the poll for that one, which is great as well. And then I'll open up another one too, which just is about like, how would you describe your team's current DevOps maturity? But then later on in the presentation, I might tune how I talk as we navigate through that. But let's start talking about why most teams hit a wall, and honestly, like how AI is going to unlock that momentum as well. What I will mention, so my coworker recently wrote a white paper based upon all of his experience working with numerous companies and industries with chaos engineering. And what he concluded, interestingly enough, with like where people hit a wall is with just change management. As simple as that sounds, it is really hard. Like when you're putting a new practice into place, whether that's something, with the culture or a tool, like change management is what really needs to occur, right? And this white paper is actually in the resources. It's not gated, so it's free to download. But you can kind of see how some best practice in change management, as far as just like project planning, getting leadership involved, teaching the organization through tech lunches every week. All these things can help you better adopt chaos engineering or just any new tool or practice. Yeah, change management has always just been hard. And I even remember, like working at Excel Energy every day, Monday through Friday at 7:30 in the morning, we had a change management call just to talk about all the changes that were happening in the environment from yesterday to today and what incidents have occurred. Um, so it's very, very manual process. But yeah, this white paper, which is in the resources, kind of guides you through some best practices for change management, which you can also apply to chaos engineering and introducing it, which is great. But what we've seen from a product perspective over the years too is once you get through change management, um, the adoption challenges with chaos engineering are really around difficulty in determining what experiments to be created, which experiments to run and how often, like which pipelines to add to it, like my CI/CD pipelines, like how do I navigate chaos engineering in that with the constant change that's happening with deployments. And then also like how to interpret the results because not everybody's an expert at system reliability, so it's not as intuitive, right? And this is where we're seeing solutions on the right hand side where there's auto discovery and creating experiments automatically. At the end of the day, if you run one CPU test, so you can run a CPU test to scale up your CPU to like 80%, 90%, 100%. But that one test can actually like you can learn a ton from just one test, right? So some people will get overwhelmed with I can run 10, 50, 100 tests, but in reality, like start with one test, like a CPU test, where you can see how your system handles that resource of CPU being exhausted, right? Do I get an alert? Can I see it in my dashboard? If my resilience mechanism is like auto scaling, which triggers off a CPU spiking high, like does that even work, right? Um, but we're seeing like open source tools and commercial tools go as recommending experiments, and then using AI to determine like what to create, what to run, and like how to fix it. Because honestly, my experience with running chaos engineering in like game day practices, which are like tabletops, a lot of people like will run the tests and maybe create a Jira ticket, but then they never go back to like fixing it because they don't know how. So like all these, it's fun to run a chaos test, but then it creates problems and you have to fix it. Like that tail end of the work really like developers and whatnot, they're like, it's more work, right? So if we can help on the tail end of things too, like that's where I'm really seeing AI move with that. And what this can look like with like how to design outcome driven chaos tests that reflect real world impact, right? Like um, all I did here, and this is nothing fancy. This is just me using my favorite, GBT tool. Um, but like a simple latency test, right? Me adding, you know, one 1 second or 1,000 milliseconds of latency between my application and a cache or a database or another dependency, like makes sense to me. But like, how do I explain that to my coworkers or my boss or whoever, just so that they understand the importance of it? People in the poll were talking about, they're exploring chaos engineering, not sure, or even from like a DevOps maturity perspective, they have some automation in place, fully automated, but a lot of like the unknown is just like in how you explain it. So this is like what I do all the time with like chat GBT or whatnot is I ask, like I already know this, but I'm always like, how do I communicate this easier, right? So a simple latency chaos engineering test, like why do I even do that, right? So I ask like, as act as a chaos engineer, tell me like what resilience mechanisms can be tested using latency. Because whether you're an SRE, developer, QA, there's like stuff in your code that helps protect, your application. So in this case, like a latency test, it can help with traffic routing and load balancer failover, right? Which makes sense, right? But intuitively, maybe you're not thinking about that. Or if you're Kubernetes, maybe you're trying to monitor the cluster level traffic distribution, like how my users are talking to my application across the clusters. But latency tests can help validate that that's working appropriately. And also just like a graceful degradation during high latency or partial outages. So somebody had mentioned in the poll, like I'm trying to prevent or minimize outages. like a latency test can give you that way to test that resilience mechanism in your code, whether you're using like circuit breaker, timeouts, retries. Um, and then another way to up level a conversation, right? When you're talking to your manager or leader, like you can talk about the business and technical outcomes. So in this case, right, like for business, like trying to ensure seamless customer experience during partial system outages, right? So if you are a developer talking to your product manager, if you have one, like these are things and ways that you can talk to them that they should care about, right? Like usually people, what I always find is they're okay like with an incident, because they're like, yep, incidents happen and then we just go fix it and then it's fine, right? But when you talk to a product manager or a leader about the customer experience being seamless and like how you're going to protect their investment, like these are good ways to talk about chaos engineering, or more specifically like avoiding revenue loss or customer churn during traffic spikes, or routing issues, right? So these are all ways that you can talk to the business. And then technical outcome, right? Maybe your engineering manager cares more about, but validating the traffic can be rerouted from the load balancers appropriately. So again, if you're using load balancers or you're investing in deploying your application to multiple regions, right? It's expensive. So how are you going to protect that investment to know that it's going to work, right? Is you can tell your boss, like, do you want me to wait for an incident to make sure that these work? Or I can use one test to proactively validate that it is going to work. Or if it doesn't work, great, then I can fix it and make sure I'm, configuring everything. So these are, a simple way to use AI is just to ask these questions, where I always, in my prompt, I say, give me, the resilience mechanism being tested, tell me the business outcome. I even put in words like, my leader is not technical, so I need to kind of level up the conversation so that they understand, right? And then if you have to convince like your architect, if you have like an enterprise architect, or you have to convince them to do this stuff, you can speak to the technical outcomes that align with what their goals are as well. And that's really where like I see chaos engineering evolving to. You know, the manual work that I just showed you in that one slide, right? I did that so you can maybe take a screenshot, or we'll send the slides later, but you can kind of see what you can do. But then I see tools now, right? Taking the context from those prompts and systematically creating experiments, running experiments, and recommending what should be fixed. And this is where like AI can really infuse new ways to think about creating and running tests, right? So when you look at your overall system, your application that's running on all this infrastructure, all the stuff that's happening in the world, right? You can kind of learn from it to respond to it. So like I can look at configuration of services in real time in my environment, and using AI, I can like respond to that, right? So rather than like the next day during a change management board, I see that, there's some configuration that changed, or an incident or an event that I'm responding to the next day. Like these AI systems that you build, the feeder can be all these things so that you can say like, hey, I need to go create this chaos test to prove out this new configuration. Or as my systems are running, like what events are happening in the real world, like with low traffic changes, such that it could cause me to want to run a proactive chaos test. And in the future here, like all of these events for creating and running could actually decide like whether or not a new deployment happens or a new change, right? So like today, a lot of things are passive with human in the loop, making decisions, which is definitely the right way to go. But in the future, right, a lot of these smaller things could actually make real decisions for us that we don't have to think about. Similar to like the concept of auto scaling, like years ago, like you would have to spin up servers by yourself, right? And then all of a sudden, auto scaling came out, which isn't AI, but we were going to let computers scale up, servers that cost money by themselves, right? So like now with AI, right, like AI is going to be able to do similar things. So we can slowly let, these agents, if you will, do more and more within the guardrails that we set up. Um, and I'm just going to look at that poll real quick. Awesome. Okay, great. Love seeing people just respond with, getting started, some automation in place, etc. So I'll close that poll. And the last poll, as I finish up the slides and get into the demo before we hop into QA, just talks about, what are your biggest challenges with resilience today. So here with at Harness, like we are building this AI reliability agent, where we're, enabling developers like with, no skills like or history with chaos engineering to create experiments, right? So there's that barrier to jumpstart easily into that, right? But this allows people to have tests to start off with, understand why they need to run this test, and then ultimately like know what to fix, which is really great. And that's what I'll kind of walk through in the demo. But before I get into the demo too, I was going to just talk through some real world use cases of how we're using chaos engineering in these new AI systems. And I have some word slides, I know, but good for screenshots. But if you're building, an LLM, or if you're using an LLM, right, like how are you handling an outage or like a model failover? And I don't know if anybody experienced this, with like the Google outage just a few weeks ago, like where they actually had a Gemini outage too. But how are you handling like the LLM failover with the agents that you're building, if you are, right? Or if you're using a third-party service, that's an agent, like you should ask questions like how are you handling, you know outages like with the provider, right? And these are simple questions to ask just like with any outage, but now with agents and LLMs we have to ask these same questions. Like the questions maybe don't change at a high level, but we have to understand the failover. And what we saw like with this outage too was like a lot of these models that were using, SaaS models, right? They didn't switch over fast enough to maybe like their backup, like OpenAI model, right? Or OpenAI had such an influx of customers asking to switch that there was like a backlog, a pause, a wait, right? So you have to understand like how these models fail over, and then like the agents ultimately, like what do they do as the model's failing over, right? And that's where a lot of people are looking at, self-hosted LLMs and all that kind of stuff. But these, again, like to me, this is like a disaster recovery strategy that you can use chaos engineering techniques to prove out and test. Two more of these as well. So like if your agent that you're building loses context or the data corruption, like how are you going to test that, right? So that there's not like these dangerous outputs, right? Because agents, we can program them to detect malformed, incomplete, or missing context, right? So they don't happen in this, and you can use chaos tests, right, to inject corrupted or truncated data, basically, right, or mess with like the headers and certain things. But again, this could be like a real world example where, let's say, like an incident response assistant, um, which again, maybe you're not building that, but maybe you're using like an incident response tool or something else where they're using that and you need to ask these questions. But if that incident response assistant is receiving some partial context, like what happens, right? Like, what are you going to do? Or like at least like at the nuclear power plant I worked at years ago, when there was like bad information or not accurate, like on our computer system, there'd be a little like red X or a yellow icon that would just signal to the operator, this isn't 100% accurate. So there's just certain ways you have to test and build these things. And then lastly, too, multi-agent coordination failure. Like this becomes more and more challenging, but like if you have like a DevOps assistant workflow and one agent is doing one task and another is doing this task, like how do you handle and coordinate failure modes? So like I love these LLMs and agents that everybody's talking about, but there are new failure modes that we have to protect and test against. And I don't see many people thinking or doing this yet. And this is, where more chaos engineering practices are even more relevant. So these are just little snippets of everything. If you're interested in that as well. And again, if you're not building agents, totally fine, but you're probably going to start interacting with a vendor that is. So then these are some questions you can ask them even during like a third-party vendor risk assessment. So I talked a little about, the model context protocol earlier, and Harness, we just released an MCP server as well. So, we are building these agents that can interact with the MCP server. And more importantly, if you are building your own agents or using, your own LLMs, this is where MCP is important because it can actually interact with that, right? So, like today, we have a UI, we have a CLI command line interface, we have an API for interacting with chaos engineering. But now in the new way of things with MCP servers, talking with your code editor tools, you can actually engage, right? So we're meeting the developer more where they're at, so they don't have to leave their code editor, for example, and go to other screens. And ultimately, what this engagement looks like, as simple as this is, I mean, this is kind of like when you call an API to say list out my chaos experiments. But using this, you can have a conversation where you say list out my experiments that I want to test, run this specific test that's pre-approved, describe it. I had a bunch of slides before that were describing things, so now you can in your code editor you can describe the chaos experiment and tests, right? And most importantly, the results. So as developers, are working in their code, building, testing, deploying within their code editor too, and now they can test in a new improved way. And what this looks like, right? This is just a Claude example of interaction too. Is is this. So it's again just like you're having a conversation with ChatGPT to write some content or a blog. Now you can have a conversation where you're saying, configure, start, run, all in human language, right? So this is new from when I originally posted the abstract for the webinar, because things are happening so fast. But we're trying to stay ahead of how developers and SREs and platform engineers want to work and where they work. So I got to my demo here, which will be pretty quick, and we'll have plenty of time for Q&A. But I'm looking at the last poll too. So a lot of people are saying their biggest challenge is around tooling complexity. Yes, amen. That's certainly a problem. And then not prioritized by leadership, right? And that's the biggest failure that I see in the industry with chaos engineering programs is the leadership doesn't prioritize it, which is interesting. And maybe the slides where I was telling you about business outcomes and storytelling could help you think differently, right? Actually talking to your leadership to be here's why you should prioritize it and how it relates to maybe your KPIs or goals, especially around, availability or downtime. Because at the end of the day, you have to learn how your leadership thinks and talks, because we don't all talk the same. Cool. I'll close that poll. Checking out questions. Got a few questions. Please ask some more questions that I'll get to as well. And then I'm just going to switch screens for demoing here. All right. Okay. So I am on our harness product as well, right? And if you want to learn more about this, more one-on-one, click the links that are being sent out as well. Happy to book a demo or talk with you just, on Zoom or Google Meet or whatever tool you use. But with the harness product here for chaos engineering, I just want to say, we have I always like to tell people we have 200 plus tests you can run. I think we're up to 230, 228 right now. It seems overwhelming. And this is why we've kind of built these AI features, right? So with Harness Chaos Engineering, right, you can go into your Chaos Hub, which is your repository of tests. And we have all sorts across AWS, all the cloud providers, Kubernetes, Linux, Spring Boot, VMware, and even bring your own chaos so you can containerize your own tests and then utilize our platform to orchestrate it. And we also have a cool feature called application maps for Kubernetes, where we can actually surface the services and dependencies using some underlying technology, so you can kind of visually map out and orchestrate your testing, and more importantly, your resilience scores. And if you think about that leadership conversation I just was talking about, maybe this type of visual would help your leader, understand here's what I need to test, here's my current scoring and coverage, and this is what I'm trying to protect against, um, which is great. But what I wanted to get to today about was our AI reliability agent. So today, when you install like our lightweight harness delegate to run tests on your system, you can enable or disable like this AI reliability agent. And out of the box for your services, we recommend certain tests that you can create new and run. What's really great about this is when you hit create, it's all pre-configured, so you don't have to click even more buttons to like say which deployment or which label or etc. It's all pre-configured based on what we know about Kubernetes. And in the background, not on this screen, what I'm doing to one of our services, I ran a command just to reduce the replicas from 2 to 1. So basically like 2 servers to 1. And based upon that change, like I was telling you about, like the AI feeder, it's going to recommend a test, which it should populate now, um, just with this pod delete test, right? So all these tests that are recommended, what we're trying to do is give you that pre-populated list that you can easily run, and then explaining it with the context, right? So currently, like this pod delete experiment actually recognized that it changed, right? The deployment currently only has 1 replica, which is below the recommended 2 replica set, right? So maybe in the future, it would prevent me from changing the replicas. You can set up policies like that. But in this example, like our AI reliability agent recognized this configuration change, and it's recommending you run this test, which would prove that it fails, right? Um, so if I go to a previously ran test for this, what I can see here is that this test was recommended, and walking through our platform here. Um, so first, again, like I mentioned before, we're not just injecting the fault and the failure. We're an end-to-end system test workflow engine, is like what I like to say. So like the first step is like evaluating the rules. Like, can I even run this test? Is it safe to run it? Do I have the role-based access control to run it? We can actually set up to say like, Matt cannot run this test on Fridays between 8 and 10 on this Kubernetes cluster or node, right? So very, very granular security. But then this test that I actually recommended with pre-configured resilience probes that measure the health of your system, it actually is able to run it and kind of show you what passed or what failed. And then what's great about our tool as well is you don't have to go like log into Kubernetes, in a terminal prompt. We actually show you what's happening here on the screen with the logs of everything. So you can actually see how Kubernetes is reacting with your application, how we're killing a pod, and like the health checks that are getting measured, failing, and all that, which is really great. And then what happens after the test is in our resilience probes, if I click on that, I should now see some recommendations, right? So just to kind of like backtrack a little bit too, like again, we're creating a chaos test for you based upon changes in your system, telling you why it's important to run. And then after you run the tests and we have measurement in place automatically, we're actually telling you like what you could do to fix it, right? So if you click on fix, we're not going to actually fix it today, but we're giving you, what happened to the service and then context around like why it happened, right? So you can acknowledge it, ignore it, or my favorite, create a Jira ticket that goes on your backlog that you can prioritize specific to this test to fix. So it's been a great way to help teams onboard quickly, give them that to-do list to run fast. But most importantly, we're not abstracting the information and learning away from the user. We're providing more so they can think differently and learn about it. And you can imagine in the future, like as these agents have more control, right? Maybe if I do go to scale down something, there's some blocking or preventing certain ways, such that these tests can get automated in a way that where it's just continuously measuring their resilience. And you might say, Matt, that sounds a lot like a monitoring tool, but monitoring is just static listening. But what I'm talking about more is like active reliability management. Um, so another quick tab I was going to go through as well, and this was on the abstract of one of the learnings, but how can you take your current CI/CD pipeline from start to finish and incorporate chaos testing? And in this window that I have here, this is like the broader harness platform, and this is like our end-to-end tests where we're going from build, um, test, and deploy. And what we can easily do is add chaos tests into your pipeline. So in this case, I have a QA deployment. I'm running 3 tests in parallel. And these aren't random tests. These are, tests for a purpose. And if they fail, it's going to block the deployment. So it's really easy to add these tests automatically into a pipeline, which is a template that you can run continuously as you need without any further configuration. And the screen that I'm showing, it's a building block for building your pipeline, and there's no scripts behind it. One time I was demoing this and somebody's like, well, where are the scripts? Because they're used to using like Jenkins. But there are no scripts behind this. This is all programmatic templates. But you can also, whether you use Harness or like GitHub Actions or Jenkins or GitLab, we can integrate with our API for that testing as well. All right, so I'm going to go back to the presentation and land on Q&A here shortly. But these are some other fixes that we present customers and users. In my demo, I didn't get to show you this, but this is another fix around like timeout duration and deployments with latency. This one is just around like a failed server status. Very simple, but again, presenting the user that context an error message so that they can go and learn and fix. But before I get into our Q&A as well, like Harness Chaos Engineering, like our journey ultimately started in 2018 with the creation of the open source project Litmus Chaos. In 2022, we joined Harness and we built our enterprise chaos engineering platform on Litmus Chaos. Litmus Chaos is just for Kubernetes. So what Harness has done is built chaos engineering beyond Kubernetes to support PCF, to support OpenShift, Linux, Windows, etc. So that's really kind of where our enterprise model has grown. But over the years, we always kind of like to think about 2.0, 3.0, and 4.0. And, we've grown from 40 tests to 228 plus tests. And today what we're giving developers, like what we talked about is, application chaos where they can do resilience, AI powered chaos. And then we've built out an incident response tool, which I didn't talk about today, but they go hand in hand and playing together with that. So these are a lot of our capabilities that I didn't cover that I'd happy to cover in a demo in the future as well. And I wanted to end on these slides, like I talked about before, like 25% increase in coding, and we really need to help developers with build, deploy, and test. And that's where like Harness has built this AI tech stack with our agents, right? Leveraging various LLMs or eventually, customer LLMs to have these Gen AI services so that, we can manage the cost of it, monitor the logging and security. And there's another talk on this that we'll have another day, but ultimately, like, this is the tech stack we're building. And we really just want to help, as you increase the coding, to 25%, we want to help you increase that to delivering to your customer, right? So that's where we can help with build, test, secure, deploy, and optimize. And that's what our platform looks like today, with many different modules. Best in breed can be used individually or together. And then we have a multitude of agents that interact with these modules for your business outcomes that you're trying to achieve. So thank you so much. I got some QR codes here for the website, my LinkedIn. If you want to book a meeting with me, I've had a couple people be curious enough to select that QR code and book a meeting with me on my calendar. But I'm going to jump into Q&A in the last 4 minutes, and then we'll let you go for the day as well. So as far as Q&A, going through to as well. So do AI agents come with an accuracy rating. So that's a good one as well. Um, so this is interesting too. So we that's how we're thinking about like when we deploy a new application or a new service or an agent, like exactly like what's the SLA that we can provide the customer, whether it's like a self-hosted agent or SaaS, um, which is super interesting to think about. So absolutely, you have to think about that with service level objectives and everything. Um, let's do another question. So, like, what are some early indicators that your team is ready to adopt chaos engineering? Like in reality, you're probably doing some sort of manual chaos testing today. If you're responding to an incident and part of your analysis afterward is to go like recreate it to test that you fix it, like that's chaos engineering in itself, right? Um, how do you measure the success or ROI from resilience testing initiatives? So in our product, we offer, like the resilience score and coverage. So that shows you like success and ROI. But ultimately that leans into like less outages, less downtime, faster response time, which is what your leadership cares about as well. Um, looking through a few other questions. There's one around are there metrics based on waterfall or more agile Scrum environments? I haven't answered this question before, so it's interesting to think about. Like I grew up in a waterfall environment with delivering technology or more agile. What I would say, like if you are in like a waterfall development, which is totally fine, there's tools that are like that for sure. Um, Usually have big bang releases, so you can do testing around that with your QA team. Um, and the metrics for that are usually go, no go with those big releases. But I would encourage you to, adapt more agile Scrum environments where, if you have a 2 week Scrum sync, you're testing every 2 weeks with like a chaos test just to kind of see if there's any configuration drifts in your system. Um, let's see, what kind of team roles or collaboration models best support chaos engineering adoption? Um, Yeah, I mean, I'm seeing SREs do it. I'm seeing QA performance engineers do it, especially in lower environments. And where you can collaborate with those teams is like the developer and like the QA tester performance, like generally have like an agreement of what test suite they're running. So they collaborate with those tests and frameworks and couple it up with other habits, like I mentioned before. And I also see like functional testing, like with unit testing, developers are more introducing these tests with those functional tests as well. So that's great. AI hallucinations, question on that. So how's AI a reliable agent? Yeah, so there's enough. That's probably another conversation for another day, but there are best practices for ensuring preventing hallucinations with running certain tests. And that's where we're at as these like QA engineers and tests, like they're going to be so important in this new AI world for testing hallucinations and everything. Um, and then are there risks or downsides to using AI in failure testing or chaos aided automation? Sure, there's always risks with everything, but slow, methodical process that's tested and true. You try to recognize what's risky about it. I would say a lot of companies are abstracting the context away of learning, so it's important that anything you're automating, you can learn. But that's all I got today. I really appreciate everybody's time. Thank you for joining so much, and looking forward to our next conversation. So, thank you so much.